Hey folks, welcome to my channel number 10. There we have the problem on our screen. Find the derivative of the following function with respect to the corresponding independent variable t. F of t equals t cube into cos of t, right? So we notice that this is a product of two functions, right? So what are those two functions? Let's write them down. If I'm going to call those individual functions u and v, what is my, in this case, it's no longer x for this particular problem, it's t. So let's remember that. So my u of t is t cube. My v of t is cos of t, right? And in my previous videos, I've solved for dy dx of cos of t using first principles, and I've probably put a link uh, in my description to those videos. So I know that my f of t is nothing but u dot v, right? And what is my dy dx of t asked to find? So that is f dash of t is nothing but product rule. I straight away go and apply my product rule to this particular equation, and I get right. So it is uv dashed plus vu dashed, right? So let's do that. Plus vu dashed, right? So let's move to the next line because we'll have to solve for v dashed and u dashed. We know what is our u and v now. So I know my v is cos of t. So my v dashed is minus of sine t, right? Because that is d by dx of cos t. But then we have a t cube with us, right? Which is our u of t, right? So before I solve for t cube, let's generalize this and let's say call it g of x, right? Let's call it g of x and solve for, say, x to the power n, right? So let's call g of x equals x to the power n, right? And I'm gonna use x, and let's replace the x by t when we solve for this towards the end, right? All this is because I want you to understand how do we solve for x to the power n using first principles, and then remember that particular formula and apply that in the problems that we come across, right? So we're going to solve for x to the power n, folks, using first principles, and then apply it back in uh, t cube, or any function that you come across which is of the type x to the power n. For example, it can be x cube or x to the power 4 or x square or x to the power 5 or whatever it may be, right? So you're going to see a lot of this as we do more and more problems, right? So I'm going to solve for g dashed of x. So let's move to the next line. So what is my g dashed of x? So g dashed of x is, so this is my g dashed of x, right? Limit h tending to 0, g of x plus h minus g of x divided by h, right? And what is my g of x plus h? My g of x plus h is nothing but x plus h the whole power n, right? I'm just going to replace my x by x plus h minus n minus x to the power n, right? Divided by h, right? Now I know what is my x plus h the whole power n, right? I'm going to expand this using binomial expansion, right? And what is my formula for x plus h to the whole power n using binomial expansion? Let's write that down. This is what it is, right? And remember, I still have my x to the power n. Don't miss that out. That's a common mistake that all of us, including myself, we tend to make. So this is what we have, folks. Limit h tending to 0. I've used the binomial expansion for x plus h the whole power n. I've rewritten this as x to the power n plus n x to the power n minus 1 into h plus n into n minus 1 divided by 2 factorial into x to the power n minus 2 into h square plus n into n minus 1 into n minus 2 divided by 3 factorial into x to the power n minus 3 into h cube, and so on until we have h to the power n. And then remember we still have the minus of x to the power n here, right? So I can cancel out my x to the power n, right? So I can cancel out this, and I have my the next line, limit h tending to 0. Remember, folks, I've removed my x to the power n because I've cancelled it in the previous step. And then I have my h in the denominator, which gets cancelled out, right? So I'll just show it to you in the previous step itself. So I can cancel out this h. And similarly, in the second part of the numerator, which is my this expression, right? For example, I can cancel out one h, and my h square becomes h, and similarly in this expression, my h cube will become h square, right? And so when I write this expression, which is nx to the power n minus 1, becomes independent of h. All the other expressions are going to have an expression which has got a h with it, right? And we've got nothing in the denominator now because we would have cancelled out the h in the denominator with one h in the entire numerator, right? So when I rewrite this, I can rewrite it like this, right? My h cube here becomes h square, right? And similarly, I keep going, plus I keep going to h to the power n minus 1, right? So this is what I have with me here. My h is cancelled out, so I have a 1 out here in the denominator. So all these expressions, right, which still have a h, I don't think we can further simplify them, right? So let me call them by a different color. So let me call them by an yellow. My substitution of h as h tends to 0 will make this entire yellow expression 0, right? And the expression which is independent of h is now nx to the power n minus 1, right? So I can copy that, and all the remaining expressions become 0, right? So which means my other expressions are 0, and then I have a 1, and I'm left with nx to the power n minus 1, right? So this is what we have when g dashed of x, when g of x equals x to the power n minus x to the power n, we have g dashed of x is nx to the power n minus 1, right? So now I'm going to go back and substitute this in my original expression, right? So what is my x here? My x is nothing but t, because I have this expression which is dependent on an independent variable t. So instead of n, I have n equal 3 here, right? So when I calculate my u dashed, right? When I calculate my u dashed, I will have to do a simple substitution of the formula that we just learned, right? So my u dashed is nothing but n times t to the power n minus 1, which means it becomes a 3t square. So that's my answer for u dashed. And what is my v dashed? My v dashed is minus sine t, and I'm not going to explain this. Minus of sine t. And so what is my f dashed of t, which is nothing but uv dash plus u dashed, right? So when I write that, let's move to the next line. When I move to the next line, I notice that my uv dashed is, my u is t cube, my v dashed is minus sine t, so I call this as minus t cube into sine t, plus vu dashed, my v is cos t, so I retain it as it is, and my u dashed is 3t square, which I bring it here, right? So there we have the final answer, folks. I'm just going to highlight this. So minus t cube sine t plus 3t square cos t, right? So we also learned using first principles how do we arrive at dy dx of x to the power n, and it's important that you remember this particular formula, that dy dx of x to the power n equals nx times nx to the power n minus 1, right? So I hope you found this content useful. Please do subscribe to my channel and support. Thank you.